Welcome everyone. This is Professor Ma, and this is the lectures, short lectures on the sections on equations. Here is a summary of what we are going to talk about, the highlights of these sections. This is a very important section, and here's the summary. What we are going to do, we're going to review how to solve the second degree equations. We're going to define what equations are, and then we're going to look at other types of equations and the technique of converting them into first and second degree equations. Examples. We had from last sections for what we mean by our expressions, and we use these examples to create expressions for calculating how much money we have to pay for ordering X pizzas. $8 pizza, $10 delivery. So we have a way of calculating how much the cost is going to be. This is called expressions. So the cost for 100 pizza is $810. Now let's do this backward. Suppose that the pizza delivery person comes and gives us a bunch of pizza, says cost $810. And the question is how many pizzas are supposed to be there? Okay. In other words, we want to backtrack to find out the 100 in case we forgot it. Okay? And here's how we think about it usually, and we will think about it like this. We'll say $810. Okay. And we're going to take away the $10, so $800, and that's going to be the money for the pizza. And each pizza is $8 divided by 8, so therefore there's 100 pizzas. Okay. We're going to capture this backward reasonings using this setup, these equations that's in front of us. That is, we're going to write the expressions that which calculate the outcome. On the other hand, we know what the cost is 810. Remember, we're trying to get back to the X. So we set these two things equal to each other with a double bar. This is an equation. And the setup allows us to backtrack the way we backtrack inside our head in the following manners. First of all, we take away the $10. We take away the $10 on both sides. That gives us a new equations, which said, oh, the pizza part of the cost is $800. Since each one costs $8, we divide it by 8, and we get to our answer, X equal to 100 pizzas. This procedure formalizes the backward trackings. And such a setup is called equations, and the purpose of this equation is try to recover the input. Expressions are kept for the purpose of calculating outputs. Equations are backward. That is, I know the output or supposed to be output, supposed to output. I want to find out what inputs has to be in order to produce these outputs. Okay. So solving equation is backtracking, which is harder. So this is the mathematical definitions of equations. Expressions equal to another expressions. Okay. And notice in the last examples, we have the form of ax plus 10 is 810. One expression equal to another expressions. And this is really no different if I were to switch sides. Same equation. Equation setup is symmetric. It doesn't matter you put this on that, which side of which side. It's the same equations. You get the same answers. So notice these about equations. Also, these are first degree equations. Why? Because the X is first power in these equations. Therefore, the page over here, the first page says the solution for first degree equation is that it is Okay, so that first line there tells you what the solution of first degrees are. So we know how to solve all first degree. Now we'll come to the second degree. Okay. And second degree, the way we solve is first we move everything to one side and we factor. First we try the factoring method. We first make the zero, which is the vital person. It's a very important part of the process. You make one side zero and then you factor the second degree formula. And now the puzzle is what number x can I put in the position so the two parentheses multiply is zero. And if you think about this backwards, very easy. Well, x equal to, for this one, is x is equal to x equal to 2. Okay, but put 2 in there, 2 minus 2 will be 0, and 0 times whatever the front number is, it's going to be 0. So x equal to 2 will work. And think about it, the front one will produce x equal to minus 4 over 3. So this is the factoring method. Okay. These two sets of equations, first degree and second degree equations, are the most important one because from here on in the calculus class, just about every equation you have to solve, you have to wind your way down to a first or second degree equation. Hence, you have to know them really, really well. It's like once you get to a first or second degree equation, then you know you're home free. Yeah. And here's another example. How do we? Here's an equation of fractions. We're going to change into a second degree equations or first degree, depends on what it pops out. Clear denominator. Okay, so I multiply the least common denominator to everybody. Remember, if I were to do this for the first one over here, then x minus 2 will cancel, and I will be left with x plus 1 to be multiplied to the 2. But I'm not going to change it. So this is what happens if I multiply the common denominator throughout the problem. When you multiply to the 1, there's no cancellation. Hence, the entire LCD remains. The next equations, after all the denominator are gone, I wind up with this equation, and what is it? It's a second degree equation. Then I solve the second degree equation. In this case, the answer both are good. Here's another one. Here's a third degree equations, and usually we don't have that many problems third degree. Only in some specific cases when we talk about a series of equations, like in chapter 4, we'll talk about these a little bit. But if there are third degree, one thing we try is grouping. That is, the problem is made up, so the grouping will work. Let me phrase it backward. I group them into two groups. Here, the red ones and the green ones, and then each one I take out the common factors. These problems are made up, so the parentheses are leftovers are the same, which allow me to do it one more time. And this is the grouping method to solve these equations. And this reduce the, not reduce, but factor the formula into a first and second degree. Then I can get the answer out of each individual one. Okay? And the second degree factor into x plus 2, x minus 2. And now I can put 3 different numbers for solutions. Okay. Any one of these numbers will make this multiplication equal to 0. So to make the equation true. If you can factor, then you will need computer. That's what I'm saying. If you have to work equations by hand, you have to be able to reduce the questions in general down to first or second degree. If you reduce it to a third degree, and unless the third degree can be factors somewhat easily, then it becomes a computer. Okay. So, but if the formula cannot be factored, then we use the quadratic formula. And here's the quadratic formula. Okay, and then the inner part of the quadratic formula, which is very important. Okay, and here we list the properties. Okay, and what happens if the number is positive? Okay, here very briefly, if the number is positive, bigger than or equal to 0, oops. Then this number can be square rooted as a real number, then the answer will exist as real number. In particular, if these numbers in here is a perfect square, like square of 9 plus or minus is supposed. These numbers actually come out to be 3. So therefore, these properties are fraction answers. So if the b squared minus 4ac is a square number, then you get fractions, which in terms means it's factorial. If it's negative, then we don't have real answers. And we'll talk about complex numbers in next sections. And here's just examples that kind of uses rules and solve a little inequality. I'll let you read about it and solve the number k. In order for the equation to have real answers. Power equations. When we solve these equations, we take cube root. But if I use the exponents notations, it looks like this. Okay, it looks like I can change the problem by moving the powers from one side to the other side, except I reciprocate the power to the other side. On the other side. Here's what happened. I have this problem. So what I will do is I think of a reciprocal of 3 is 1/3, and I raise the power to 1/3. And these portions will 1/3 times 3 is a 1. Therefore, the effect is basically is this side is I'm going to have x to the first power. Okay. So if you think about it, I can even make that a rule. I mean, like a physical, just take the power and put it over to the other side, except my foot. Here. If I'm solving the equation x to some power equal to a number, I just reciprocate the powers on the other side for the number. That will be your solutions. Then I go from here to interpret what that number is supposed to be. Either use calculators or using, in the fractional case, interpret as roots and power. Okay. For instance, reciprocate the power. It's 16 to the crosses out and move over and flip it over. Okay. So that's the solution. And here we go. And which is what? Which in terms is 164. Think about it. Yeah. And remember, check plus and minus. Okay, that's the easiest way to capture all the solutions. If you get a plus, then check the minus. Okay. In some situation, it will work. Some will not. You can make a rules for that. Actually, it's not a few rules, but we're not going to go into that. The easiest way to solve the problem is check, double check. Okay. Here it's a binomial raised to 3 half powers. And how do we untangle these? Oh, reciprocate the power, put it on the other side over the 8. Yeah. And then on the left-hand side, the 2x minus 3 power is just the first power. So it's just 2x minus 3. Notice now the problem is a first-degree problem. This is what I'm talking about. Every one of just about all the problems you will see, if you want to solve by paper and pencil without calculator, you have to be able to do these reductions. There's a radical equation. How do we do it for equation with square roots? Here, let me put this formulas over here. Just get it ready. Okay. How do I solve for these? What is x? First, what not to do. Okay, some people will say, oh, let me square these, let me square these, I don't like the square root, so that I will get 5x plus 4, 16x. No, you cannot do that. Okay, why not? Here, square of 4 plus square of 9. I'm talking about 2 plus 3, of course. And that, of course, is 5. In other words, this is 5. I cannot do the following. I cannot say, oh, let me square that, and square that, and square that, and everything will be fine and dandy, so that no problem that I will square, I will still get the same relationship afterwards. 25 is going to be square of 4 squares 4. And square of 9 equals 9. Then I get the 4 plus 9 equal to 25. You get a bunch of nonsense. What you meant to square is the square of these. The square of the left-hand side entirety is equal to the square of the right-hand side entirety, which is 5 squared equal to 5 squared 25. This is the correct progression of the symbols, not just squared individual ones. Okay, so we need to do these. And this is where the formula comes in, because when you square the sum, it doesn't come out quite clean. It has a square root of x in the middle, which still persists, meaning you have to do the squaring one more time to get rid of that square root of x. And before we do that, we clean it up, so make the squaring a lot easier. So we move to one side and we can divide by 4, divide by 4. So I get these versions. Now square again to remove the square root. Voila, our second degree equations. Okay, we'll have to some way of manipulating down to these problems in the second degree equation. That's why you rarely see problem like this. Square of x plus 4 equal to square of x plus 5 plus another square of 3x plus 8. Like just make it like 3 square root. To do this one, you need to square 3 times. And if you square this again, well, here we square twice. And if you're going to square, you have to square root again, and you wind up with 4th degree question. So therefore, you don't see those kind of problems because it's not doable by hand. Anyway, so solve these and check the answers. So that's how we solve the equations in general. And then there's some special type of equation, like the absolute value equations. Okay, first of all, let's talk about a little bit about what absolute value means. Here's a line. We'll kind of go into the next section a little bit in the future section. And here's a number. Remember, we can always mark down x. Okay, and then think about ruler. Okay, and then the distance from the point x to 0. That distance we call absolute value of x. Okay. So if here's minus 5, and the distance to the center 0 is 5. So we will say the absolute value of minus 5 is 5. And what's 5 in relationship to the number minus 5 itself? Minus 5, that's a number we're talking about. To make it into a 5, we put an extra negative sign to it to make it into 5. Meaning I want to talk about the distance. I don't want the sign related to it, okay? So it's never negative. And here's the algebraic definitions, okay? And if the number x is positive, then it's itself. If the number is negative, let's read this sentence in the following manner. If this number you're looking at, staring at, is negative, minus 5. I know what the answer I want to be. I want the answer to be positive 5. And how do I turn the minus 5 into a positive 5 answer? Give it another x minus sign. That's what the second line is saying. So this definition, it basically is an instructions how to produce that absolute value. So this doesn't have any solution because distance cannot be negative. And this is an important fact about absolute value. You can split up multiplications, but very important not for addition and subtraction. 3 minus 1, just test it. But actually, this is not a very good one. Here, that's an example here. Okay. So how do we solve absolute value equation? We really cannot solve it until you remove the absolute value. You say, well, then what? Well, then you have to remove it so that hopefully that the way that after the absolute value is removed, we have a solvable first or second degree equation, or something that we can change into first or second equation. Okay. For instance, absolute value x equal to 3. All the absolute value equations we're going to see will change into 2 equations without absolute value, because the distance has 2 sides. In other words, in these problems, x could be 3 or negative 3. Similarly, if I have expressions, absolute value is 5, then these numbers that I'm looking at, there's only 2 options. It could be 5 that's in here, it could be minus 5, and each one produces an equation. And then from the equation I can solve for this, and this one x, 2x equal to a. So from this one I get x equal to 4. From this one I get 2x is equal to minus 2, and add 3 to it. And I get x equal to minus 1. So dropping the absolute value sign usually wind up with 2 equations. Positive copy, negative copy on one side. It doesn't matter which side you put a negative signs on. And how about 2 absolute value? Same principle. In order for 2 absolute value to be the same, very simply, y is equal to absolute value of 4 minus. Then y has to be plus 4 or y has to be minus 4. Okay. So similarly, these equations, when I drop the absolute value sign, I get 2 copies. And then each one produces an answer. What's the meaning of absolute value of between 2 numbers x and y? X minus y. Of course, this is the same as y minus x because they are negative numbers of each other. Well, here's the point. If I have 2 numbers here, let's say 5, 2, and I want to know the distance, and let me call one number a, one number b. You know what? Yeah. Then to get the distance, when we read this off the ruler, we have to read the number on the right first and subtract the number on the left. Okay. So in this, the distance 5 minus 2. You say, well, what I mean if I just kind of absent-mindedly subtracting the number, but in different order, 2 minus 5, then you wouldn't get the distance. You will get negative of the distance, minus, right? So that's why we slap absolute value around it. So that's say, well, you know, make sure that you adjust the sign. If you, in case you didn't know who is to the right, who's to the left, okay, just make sure you subtract, then you adjust the sign into positive. And that's the absolute value. So in other words, absolute value being x minus y is the distance between the 2 numbers, x and y. So I can solve these equations, and this equation now becomes as a geometric meanings. Okay. So now we are talking about a distance from x which I don't some number variable, to a number C. And here the C is going to be a fixed constant, and R is a fixed constant. And this says from the center C, we go out distance R like a compass. And the two endpoints over here have the distance R to C. So in other words, the geometric problem is what are the coordinates of those two points, two boundary points. So of course, one is C plus the number R and the other is C minus R. And so this is the geometrical solutions for that equation, which actually has geometric meaning. So this has a geometric meaning. I'm looking for from the center C, 12 units. From house number 7, go out the block, 12 units. What's the house number? And go down the block, 12 units. What's the house number? So add 12 and subtract 12, and I get the house number 19 and minus 5. So this is geometric interpretation for the absolute value equation. And this is how we turn them into pictures for first degree or second degree equation. What else we solve equations for? One very important thing for us later on is to find the zeros and domains of different form of equation, in particular fractions. Okay, so in the future, the following problems will be asked. About fractions, they will ask you, what's the zero of f? That is one number I put in, I will get f become zeros. And then ask what's the domain of f, which means what numbers are allowed and what numbers are not allowed. Okay, the domains are the numbers that we allow. So for 1 over x, the domain is everything except 0. So that's a domain. How do we get those two questions, the answer for those two questions? Well, to get a zeros is where the top is 0, the numerator. So if I want to find the zeros for this formula, I look at x squared minus 1. The zeros for x squared minus 1, numerator is 0, then it's the solution for the formula. Then if I ask the question, what numbers is undefined, then I'll be looking at the denominator. Whatever make the denominator 0, solve the equation x squared minus 4. And so you can put in any number except x go to plus or minus 2. Okay, that's it. Okay, and do all the homeworks and have a nice day. Bye-bye.